All right, good day, everyone. We're here again to take a look at simultaneous equations. And at the end of this lesson, you are expected to be able to solve simultaneous equation using elimination method and using substitution method, using graphical method, and solving simultaneous equation involving one linear and one quadratic. And also, lastly, we'll be checking out what problems that leads to simultaneous equation. So basically, we'll be exploring mode of interpretation in that regard. And we should be able to explore one or two questions on special cases. I mean, questions that don't exactly directly look like a simultaneous equation. Of course, we see how we are to go about such. Simultaneous equations is a system in which you have two unknowns or more. Yes, you can have two unknowns, you can have three unknowns, you can have four unknowns. So in any case, when you have more than one unknown, when you have more than one variable, you can refer to such a case as simultaneous equations. By the word simultaneous, we mean that we are involving all the equations available provided. Okay, so meaning that as you're solving in one equation, you're also solving in another equation. That's why all of them are active through your solving. Okay, so now when you have a simultaneous equation in two unknown, of course you're expecting by that you have at least two equations. If it is three unknown, you need at least three equations. If it is four unknown, you need at least four equations. If you have less than that, you won't be able to solve for the unknowns, except there are other contexts that is provided. Okay, if there is no other context, such a question might have an issue. So those are the requirements when you're solving a simultaneous equation. Also, looking at the method of solving simultaneous equation, we have a lot of those methods, but for the purpose of this lesson, we'll be checking out three of them. The first one is elimination method, we have substitution method, and we have graphical methods. Okay, so all these methods are what we'll be exploring. We'll be solving questions on them. Of course, if there's any area that's not clear to you, you can just do well to listen and watch the video again. I believe it will make sense eventually. Okay, right. So elimination method. We have a question here. We have to solve the pair of simultaneous linear equation using elimination method. Okay, so we're going to be starting with the first question. We'll be starting with the first question, which is x plus y equals to 5 and x minus y equals to minus 1. Okay, for the first question, we can tag x plus y equals to 5 equation 1. Okay, if we call it equation 1, that means the second equation will be equation 2. Now, this tagging of equation is very, very important because it's when you have it properly tagged, that's when you can easily reference them. So what we mean by referencing them is maybe we need to refer to it, use it. So we need to make it known that this is the equation that we are referring to there. Okay, so it's for ease of reference. That's why we have those equation tag, and that's why we use it a lot in mathematics. Okay, so now if you're using elimination method, by elimination method, you see it's from the word we have eliminate. Yes, eliminate. So now by elimination or by eliminate, we mean we are removing one to find the other. Okay, for instance, we have xy here. Now we decide the one we want to remove. For this case, we have is a case of already having similar coefficients. Okay, so now for the coefficient of x here is 1, here x here is 1, y here is plus 1, y here is minus 1. Now, depending on the one we are deciding to eliminate, for instance, if I say I want to eliminate y here, now that's where the issue of once the coefficient that we are trying to eliminate, once the variable that we are trying to eliminate is already having different sign but the same numerical value, okay? What I mean by that is there's 1 there as the coefficient, this is like 1, this is also 1, so that's plus 1 and minus 1. Are we together? Okay, so now if you have plus 1 and minus 1 there as written there, you can easily say, okay, because they are of different sign. Okay, let me just write it this way. Different sign. When you have different sign, you do what? You add. That's what you do when there are different signs for the one that we want to eliminate. So because in this case, we are deciding to eliminate y, okay? And because they're having different sign, what you do is you add the two equations. You are not just adding the y, you are not adding just this, you are adding the two equations, okay? So that being said, okay, if we are adding the two equations as we've just stated, then let's do it. Okay, before I also move on, they have the same sign. If they have the same sign, okay, if they have the same sign, of course, what we do is we subtract, which we otherwise call we minus. When there is same sign, we do what? We minus, or we say we subtract. Okay. All right. So let's move on with the question we are trying to solve. And since it is to eliminate y, we had equation 1 and equation 2, just like we have explained. Okay. So now, if you have, of course, this equation 1 and you have equation 2 here. So what we are simply doing is we are adding them. So if you are adding them, what you just simply do is do the addition. Okay, if you are doing the addition, that means we have this, and from there, by the addition, this plus this, we know it will give us 4. That's if you're adding it together, and this will give us 0 plus 1y minus 1y will give us 0, and this x plus x will give us 2x. So that's why we have 2x equals to 4. And we can proceed by dividing both sides by 2. If we divide both sides by 2, we have our x to be equals to 2, okay? So after getting the 2, getting our x value to be 2, then we can then slot in the value of x into equation 1 or 2. You can choose any of the equation to use, but in this case, we choose equation 1. If you choose 2, you will be correct in this case for elimination, because what you got here, you got it from combining the two equations. So it means the value should be able to enter any of them. Okay, so now from what we have there, we have our equation 1 to be x plus y equals to 5. If you put x equals to 2 into this, so that means you have 2 plus y equals to 5, which you can then invariably say y equals to 5 minus 2. Okay, y equals to 3. That's our final answer. That means our x is equals to 2 and our y equals to All right, let's take a look at the second question. We have x plus 2y to be equal to 5. That's the first equation. And we have x plus 3y to be equal to 8. That's equation 2. Okay, to eliminate x, we subtract. Like we have earlier said, that for us to subtract, it means we take a look at the value that we are eliminating, which is x in this case, and the value here, minus 1 and 1, they are both having the same sign. So we said same sign will mean what? That's we subtract, okay? We subtract, very important. Same sign, we subtract. If we are going to subtract, of course, you can do it whichever way is more appealing to you. You can do equation 2 minus equation 1, or you can do equation 1 minus equation 2. And in this case, we are doing equation 1 minus equation 2 because we are to subtract equation 2 from equation 1. Of course, which by that, we write equation 1 first and equation 2 next. If we do the subtraction, of course, that minus will cut across everything. The minus will cut across everything. So this place will become minus. This place minus times plus will become minus 2. Okay? And this place 2, minus times plus will become minus. So, and that will give us the next value, because 5 minus 8 will give us minus 3, and 2y minus 3y will give us minus y. Of course, invariably, if we multiply through by minus 1, we have our y to be equal to 3. So after getting the first value, which is our y, we substitute y equal to 3 into equation. Like I said, you can use any equation. I decided to pick equation 1. Okay, so that means you have our x to be equal to 2 in place of y here. That's why we have the 3 here. That's what we have put in this place. Okay, so from what you have there, you can easily say that x plus 6 will be equals to 5, and x equals to 5 minus 6, which is going to be minus 1. So we have our two answers. X is equals to minus 1 and y is equals to 3. X equals to minus 1, y equals to 3. Okay, so now let's take a look at the third question, because we have 3m plus 2n equals to 7, and we have a 4m plus 3n equals to 10. If you have it that way, you can say to eliminate m. Now, if you look at these ones now, their coefficients are not the same. So now, the first thing you do is to achieve equality of the coefficients. Yes, that's equality of the coefficient to be eliminated. For instance, we are choosing m here. So that means we look for a way to make this equal. And you know the rule in mathematics is whatever you do, in any case, you must always maintain balance, meaning that you must not have tampered with the whole value of the equation, as it were. So from what we have here, we can conveniently say, if we're going to make these coefficients the same, that means we are going to flip their coefficients. How do we do the flipping? The coefficient of m here is 4, and the coefficient of m here is 3. So then you multiply this one by the 4 that is here, and then you multiply this one by the 3 that is here. Okay, are we together? All right, good. So 4, this from here is the 4 because we want to eliminate m. Okay, so 4, everything multiplied by 4, and everything here multiplied by 3. Okay, which is what we're going to do. Equation 1 multiplied by 4. Of course, if it's multiplied by 4, you know, 4 times this will give us 12m, and 4 times 2n will give us 8m. Why you get the equivalence of 4 times 7 to be 28. Okay, so now we do the same thing for the other one. Don't forget, we said this times 4 and this times 3. Which is what we are doing here. So equation 2 times 3, what is it going to give us? That means we have a 12m plus 9n equals to 30. Now, these two values have given birth to another set of equation. Yes, this the multiplier has helped us given birth to another set of equations. So we can target equation 3 and equation 4. Don't forget the reason why we are doing this is so that we can be able to easily refer to that equation. Okay, so now that being said, we can then conveniently say, since these coefficients are the same now, are we going to add or we're going to subtract? So what do? Then we can say we subtract equation 3 from equation 4. Okay, like I said, you can decide to subtract equation 4 from equation 3 or equation 3 from equation 4. But whichever way you are doing it, make sure you state it as appropriate. You will still get the same answer. I am subtracting equation 3 from equation 4, meaning that equation 4 comes first and equation 3 comes next to it. Just like saying I'm subtracting 2 from 5. If you are to subtract 2 from 5, that means 5 comes first minus 2. That's what I'm trying to state there. Okay, so from what we have there, we can state our equation 4, then we state equation 3. Okay, so from there, the next thing is to subtract. And if we're subtracting, of course, the minus cut across everything. Minus times plus minus, that's 12m minus 12m, that's 0. That means we have 0 there. That's a minus times plus here. It becomes minus. That's 9n minus 8n. We give us n. And a minus times plus here too. So that's minus. So that means 30 minus 28 will give us a n equals to 2. Okay, so that's the value of n. So then we can then substitute n equal to 2 into either equation 1 or 2. If you like, you can use equation 3 or 4, or just use 1 or 2. Okay, and if you do that, because those are the basic equation, or we choose 1, in this case, I choose 1. Okay, so that means we have 3m plus, in place of n, you have 2 there. That means 3m plus 4 equals to 7, and we can solve further. 3m equals to 3, and dividing both sides by 3, our m equals to 1. So we have n equals to 2 and m equals to 1 as our answer. Now let's take a quick look at substitution method. Or let's say we're solving these two equations using substitution method. Okay, by substitution, from the name, it implies that we're going to be replacing one thing by the other thing to get the value till we get the value that we need. Okay, all right, so now we have equation 1 given as 2x plus y equals to 12, and we have equation 2 given as minus 3x minus 5y equals to minus 11. That's equation 2. Okay, so now from what you have there, you can conveniently, of course, looking at this, the procedure says the first thing we do is we make one of the variable and one of the equation the subject of the formula. So meaning we can choose any equation. Of course, in any equation, we can also choose any variable first. For instance, I can decide to choose y here to make the subject of the formula. Of course, I can decide to also choose x, okay? Or I can decide to come to equation 2 and choose the y there to make the subject of the formula. Or I choose x to make the subject of the formula. So in any case, by observation, you just choose what is suitable or the one you are more inclined to. But based on what we have here, I decided to choose equation 1 and I choose y to make the subject of the formula. The reason being that it's more direct, okay? Whatever you do in mathematics, the purpose, end result is that is expected is a simplification, okay? So if what you are doing is not bringing in any form of simplification, you know that there is a problem, okay? So, or you might just be creating more problem than the solution you are trying to solve. Eventually, irrespective of what you choose, you will still get your answer, provided you are applying acceptable procedure, okay? So meanwhile, what I'm trying to say in essence is that I choose y here in equation 1 because it's more convenient, okay? Making y the subject of the formula, okay? So now, that means we have another equation which we tag equation 3. I believe you can see that. That's our equation 3. The next thing we are doing now is to put the new equation into the equation that has not been touched at all. Now, look at what the statement says. It says that substitute that expression into the other equation. Substitute that expression into the other equation, meaning the equation that has not been touched at all. If you look at it very well, this equation here was formed from this. So the one that we have not touched at all is this equation. So you substitute the expression into that equation. So that's why we say we put y into the equation 2, okay? So we replace y in equation 2. That's why we say we replace y in equation 2. In some cases, we say we substitute y equals to 12 minus 2x into equation 2. So what that one means is that this y here, wherever you now have y in the other equation, don't forget the reason why we pick the second equation is because we have used the first equation. So any equation you have used, you don't use it again until you have found your answer. You have to use something else because if you use that same equation, everything will become 0, which will not give us our answer. Okay, so now put y equals to 12 minus 2x in equation 2. So if we do that, of course, this is our equation 2, and if we replace y here by the expression here, of course, that means we have a 5 minus 5 into 12 minus 2x, of course, which we can sort out by doing the multiplication. We know that minus 5 we multiply 12, and also minus 5 we multiply minus 2x. Okay, so that means that will give us minus 3x minus 60 plus 10x equals to minus 11, which you can then sort out by, of course, getting the next value out after you have collected your like terms. Okay, so that means we have 7x equals to 49, and then we can divide both sides by 7, which will then give us x equals to 7. Okay, so from there, of course, we can conveniently say that we have solved the question for x. Now, after finding x, the next thing we have to do is to find our y. What do? You can put your x equals to 7 inside any equation at this point because you have gotten the value of one of the variables. So it will be valid, especially if you have not made any mistake in your solving. It will be valid. So the next thing is, of course, we are going to put it. Now, where should we put it? That's the next question. Where then should we put it? We substitute the solution into the other equation to determine the value of the other variable. The easiest option for us to put our value of x is equation 3. You can put it in equation 1, you can put it in equation 2. Either of them is fine. But because this is more direct, y has already been made the subject of the formula. So you can easily just slot in the value, of course, in place of x. Okay, so that means we say we put in place of x here, we put 7. So if we put 7, that will give us our final answer, y equals to minus 2. So we have our two answers. That's x equals to 7 and y equals to minus 2. That's the answer. Okay, so now let's take a look at the second question. We have the second question. Okay, let's take a look at the second question. We have x plus 2y equals to 5 and x plus 3y equals to 8. Of course, that's our equation 1 and we have our equation 2 as stated. And we have our equation 2 as stated. Okay, so now from equation 1, as usual, of course, we understand the implication of equation 1 and easily make x the subject of the formula. So if you're making x the subject of the formula, you agree with me that we have x equals to 5 minus 2y. That's from equation 1. Okay, so if you have that, we can of course say that is our equation 3. So from there, we can put x equals to 5 minus 2y into equation 2. So we know this is our equation 2. So what we are saying is that in place of this x here, we will replace it with this guy here, of course, which is what this statement is saying. Of course, from there, we have our equation 2 stated that x plus 3y equals to 8. So from there, we have 5 minus 2y plus 3y equals to 8. Okay, so it's in place of this x here that we have put this. Okay, that's why we have this. Okay, so that means, well, of course, we just collect like terms and then simplify further, in which case we have our y to be equals to 3. So from this, if you decide to substitute y equals to 3 into equation 3, like I said, you can use any equation at this point. Okay, so that means we have x equals to 5 minus 2 into 3 instead of y there. Okay, so which if you solve further, you have x equals to minus 1, which is that as far as that is concerned. Now let's take a look at the third equation. Now this is a little different in that our unknown is in form of fraction. You look at it, you have 3 over x here, you have 3 over x, and you have 5 over y. Okay, x and y is also denominator in this case too. So how do we go about it? Of course, it's something that you can solve directly if you understand the way it flows. But for the sake of convenience, it is good to rewrite it. Now, in this case, we make use of substitution. So I can call this one double substitution method. Okay, what I mean by double substitution method is we are substituting, replacing the value that we're looking for with another value. After finding the other value, then we now find the value that we're actually looking for. Okay, the statement will make more sense to you as we progress. So you will agree with me that the equation here is the same thing as this. Okay, if you agree with me, now let's take a look at the second equation too. You agree with me that this is the same thing as this. Okay, because 9 times 1 over x will still give you. So we're just rewriting it to bring out the similarity in the two equations. Now I target equation star and equation star star because they are not our main equation. So we do that also in mathematics. It's just a way not to make everything look too cumbersome. Yes, with plenty equation numbers. There are cases where it's unavoidable. If you have to have up to 10 equations, there's no problem with that. But when it's avoidable, like this case, it's not our main equation, I use star, and I'm using star star in this second equation. So now from what we have here, we can then simply say, let 1 over x be equals to a, and 1 over y be equals to b. Okay, 1 over x, of course, equals to a, and 1 over y equals b. So if we are doing that, that means all the equation will become from equation star. We can say we are replacing this with a, we are replacing this with b. So that will give us equation 1. Okay, so if we do the same for equation 2, what do we have? we have 9a plus 4b equals to 5. That's equation 2. So now we solve the equation 1 and 2 simultaneously. Okay, let's say we want to use the elimination method, and if we decide to eliminate a, if we're eliminating a, now the issue with that is 2 ways you can do it. Is either we use the flipping, meaning that the 3 here, we multiply everything in equation 2, and the 9 here, we multiply everything in equation 1. Or, since our objective is to make the coefficient of a equal, if you look at it very well, if you multiply this by 3, it will make it equal like that, is that not? But you know the rule is anything you multiply to one side of an equation, you must do to the other side of the equation. So we can multiply everything here by 3. Of course, this place we multiply everything by 1, which is what we have here. Of course, if you multiply through by 3, it will give you that. And if you multiply the second equation by 1, it will give you that as well. And from there, of course, because they have the same sign, you can subtract, okay? What we are eliminating have the same sign. So that means we say minus, of course, this will give you 0, and the minus coming here, that's minus times plus, will give you minus, that's 15b minus 4b, that's going to be 11b. And 12 minus 5 here will give you 7. Okay, so from what you have there, you can conveniently say 11b equals to 7, which if you divide both sides by 11, you have b equals to 7 over 11. So after finding our value of b, we can then go ahead and sort out the value of a, of course, by putting our b value into any of the equation. So let's substitute b equals to 7 over 11 in equation 1. So let's choose equation 1. You can choose any one, like I said, when it comes to elimination method. Once you have found one, and put your value into any of the equation. Okay, so now for equation 1, it gives us this, and if you evaluate further, of course, 5 times 7 will give you 35, okay, which you're going to have this, and from there, we multiply through by 11 to just eliminate fraction from the equation, which is going to give us this. And from there, we can conveniently say that 33a, can conveniently say that 33a equals to, so which is going to give us, that's 3 here, 3 in 33, 11, that's going to be 3. Over 11. So that's our answer there. So then we can recall, because we are recalling from here. So we recall that 1 over x equals to a and 1 over y equals to b. So if you do that, 1 over x equals to 3 over 11 according to what we have here, and 1 over y equals to 7 over 11. But let's evaluate our value of x first. So from there, you can see x equals to 11 over 3. X is therefore equals to 3 over 2 over 3. Now, for the other case, 1 over y is going to be equal to 7 over 11. In which case, we can then cross multiply to get our value of y after dividing both sides by 7. Okay, so our x value equals to 3 over 2 over 3. Now y value equals to 1 over 4 over 7. So let's take a look at a similar equation to the one we just finished. The only difference between this and the other one is this, in this case, our unknown fraction does not have a coefficient greater than 1. Yes, that's the only difference. So it's still the same mode. We'll write the equation, target star and star star. So we can then do our replacement. 1 over x equals to a, 1 over y equals to b. So from equation star, you can correctly, simply replace 1 over x by a and 1 over y by b. And if you do that, you have the value of our first equation, a plus b, is going to be equation 1. And if you do the same for equation star star, you have b minus a equals to 1, and which you can rewrite. The only reason why I'm rewriting it is so that it will have the same form as this for ease of evaluation. Okay, so now from what you have there, if you look at it very well, you discover that you can conveniently, because if we say we want to eliminate a from here and we are eliminating a too from here, you can see they have different sign. This is plus and this is minus, which you can just easily eliminate a by adding equation 1 to equation 2, which if we do, we have that, and that will give us what we need. Of course, b plus b will give us 2b, and 5 plus 1 will give us 6. And from there, you can say 2b over 2 equals to 6 over 2, which we say b equals to 3. Substitute b equals to 3 in equation 1. What's our equation 1? A plus b equals to 5. Okay, so we can just simply put b equals to 3 there, and then from there we have our a equals to 2. So the two values have been sorted. A equals to 2, b equals to 3. But that's not our final answer, and that's the more reason we have to be very careful. If you stop there, you will miss out on your final answer. That's what your solution is supposed to be. Okay, we are recalling again. We are recalling our friend here. From here, we are recalling. Okay, so since it's x and y that we're looking for, we have only found a and b, which we use as substitution to substitute for ease of operation for us to see our simultaneous equation in the light that it is. Meanwhile, you are not limited to use a and b. You can decide to use m and n. What matters is you use a different letter from what has been used already, so that you don't get it mixed up, and so that you won't confuse your examiner. Okay, so now from what you have here, 1 over x equals to 2, and 1, if you cross multiply, will be equals to 2x. That's if you cross multiply this over 1, do your cross multiplication. Okay, so you have 2 equals to 1 over x, and that's 2x equals to 1. And if you divide both sides by 2, you have x equals to 1 over 2, which you can still, of course, solve the second equation further. We have 1 over y equals to b. So 1 over y, since our b is 3, so 1 over y is 3. You cross multiply, you have 1 equals to 3y, and 1, then you can say y equals to 1 over 3. It's as simple. Looking at graphical method of solving simultaneous equation, there are a few things that are required to plot a graph. Of course, the first thing is your graph should have a title. The second one is the axis must be there, because we know that the axis is made up of a x-axis, and we have the y-axis too, which our y-axis is the vertical axis, and the x-axis is the horizontal axis. Okay. All right. So the next one is, after having your axis, you must have a scale for your axis. The scaling of your axis is what determines the numbering of such axis. Okay. And the numbering is what we refer to when we're talking about the calibration of the axis. So the scale and calibration, the scale determines how you calibrate it. Okay. And the last but not the least, required, not that after having it, it means you have graph, but it means that you can have a successful plot. The table of values. Okay. Now let's take a look at each of these things as it were. So let's say we have a graph sheet given as this, or what a graph look like. Okay. So now when you are plotting your graph, few things are very important, which we tag requirements for your graph to be said to be in good shape. Okay. Firstly, your graph must have the title. Okay. So the title, of course, is something of the form of graph of course. The equation you have here, in most cases, you will be given in the question. So it's the question that gives you the equation tag for the graph of. Of course, that should be the title of your graph in any case. So, the second one, like I have stated earlier, is the axis. Okay. So now for the axis, we're talking about the y-axis and the x-axis. Okay. So now, if we have the y-axis and x-axis given as this, we can comfortably then do the calibration. Talking about the scale and the calibration of the axis. Okay. So for the calibration, it means the way we number the axis. Okay. And the scale means the measure with which we do the numbering. Okay. So now, when talking about the scale, for instance, if you use your ruler to measure from ear to ear, you discover that's on your own graph. In your graph book, you discover it's 2 centimeters. Okay. So that's why if I want to use a scale of 2 centimeters representing 1 unit, that means this place is going to be 1, this is going to be 2, this is going to be 3, okay, and so on and so forth. And to the negative side of the y-axis, that means I have a -1, -2, -3, okay, so and so on and so forth. Okay, so now, but if I decide to use 1 centimeter to represent 1 unit, that means I have 1, that means this place will be 2, this place is going to be, we have 1, we have 1, we have 2, we have 3, and we have 4, and so on and so forth. We have 4, and we have 5 here. That's if I'm using 1 centimeter to represent 1 unit. And as a matter of fact, for the sake of clarity, you can always check. You can always check to be sure that what we are talking about is correct, in that you bring a ruler here to check. You discover that the first 4 first 5 boxes, if you measure them together, is 1 centimeter. So which fall to where the first line is. And the same thing goes for the other one. So that's why we can say conveniently that 10 boxes measure is 2 centimeter. So in your scaling, for instance, the scaling that you have decided to use here, we have a scaling on x-axis. Let's say we say 2 centimeter represents 2 units. By that, it means we have our 2 centimeter to represent 2 units. So if we say 2 centimeter represents 2 units on y-axis, that's why we have each unit to have 2, 2, 2, 2, 2, 2, and going upward is in 2s. That is, if you measure the 2 centimeter there, is 2 units. Okay, that's that. The last but not the least is the table of values. You need your table of values for you to be able to do plot your graph. You need your table of value to be able to plot your graph. Of course, you have your table of value as, of course, whatever value that result from the equation that you are given. Is the equation that will determine that eventually. Is the equation that you are given that determine what that value, those set of value will be. Because the value you have will be your coordinate. The value you're going to have there will be your coordinate that you're going to be plotting in your graph book. Now, let's take a look at a good question here. We want to use a graphical method to solve this simultaneous equation. So if you're given something like this, and you have to use graphical methods to solve it. You have to use graphical method to solve it. What you simply do, number one, you take a range of value of x. 3 values, in fact 2 in some cases is fine, but 3 is better to ensure a strong and accurate graph that is not going to be by any measure or by any dimension tilted away from the perfect line it's supposed to be. So we pick 3 points. Yes, you can actually pick any value. You can pick any value. In this case, I pick -3 to 3, but you can pick any value. You can decide to pick from -2 to 1. You can decide to even pick -5 to -2. Or, so at least 3 points. If you want to make it to be more than 3 points, it's fine. It's fine. But whatever it is, just make sure it's up to 3 points that your range of value includes. Okay? For those that don't understand this will make a little more sense. So you pick the first equation, which is what you have here. Of course, for the equation, we start by putting the value of x. You know, we say we pick a range of value of x -3 to 3. Like I said, you can pick any one. Because of the way this graph is, whatever you pick, what you just need to draw is a long straight line. After you have gotten your point, you understand what I'm saying as we progress. So when x is equals to -3, of course, you put -3 in the equation, and then you have the respective value of y, which is going to give us y equals to 0.5. So we have a point. That's when x is equal to -3, our y is 0.5. So now let's proceed to the next value when x is equals to 0. When x is equal to 0, that means 2y minus 0. You know, in place of x here, you have to put 0 there. Okay? So that's 2y equals to 4. and that means our y equals to 2. Okay, so that means we have another value, that's 0, 2. And when x is equals to 3, when x is equals to 3, what you do is you put the value of x same way in place of x in the equation. Okay, so after putting that, you have 2y equals to 4 plus 3. Okay, so that means 2y equals to 7, which you can write your y to be 3.5. So we have another point, that's 3.5. Now, why we are writing this point this way is generally in a coordinate system, when you are writing a point, yes, which is made up of 2 coordinates, yes, the x and y coordinates. So we write it in this is the general form of it, x, y. So what you have here first is your value of x, what you have here next is your value of y. Okay, so now our table is done. Okay, so this is the first table for this equation. So you can see when x is equal to 3, our y is equal to 0.5. When x is equal to 0, which is here, our y equals to 2. And when x is equals to 3, 3.5, that's x equals to 3, our y equals to 3.5. So that's what we have just done there. So now we go for the second equation, because we're going to plot the graph for the first and the second equation. So from what you have here for equation 2, which is 2y plus x equals to 6. So what you do is you put, when x is equals to minus 3 the same way, because you replace x by minus 3 and you solve your the resulting equation, you solve it further, and you have your value of y. Y is equals to 4.5. And when x is equals to 0, okay, so your y is going to be 3. Of course, the third one, when x is equals to 3, you find your value of y. Don't forget, this x is equals to 3, what we have simply done here is to replace the x here by the 3. That's why you have this. Okay, so from what you have there, that means 2y equals to 3. And then from what you have there, you say your y equals to 1.5. So you have the third point. Okay, so that means we have our table 2. Don't forget, for the first point, this is the point, and which is the same thing as this. Okay, and for the second one, we have this, which is the same thing as this. Okay, for the third one, you have this, which is the same thing as this. So eventually, you have your 2 tables. What are the 2 tables? We have the first table here and the second one here, which this belongs to this equation, and this belongs to this equation. So the next thing is to plot those points into. Now that we have our table, we have our table of values already, so it's time for us to plot the graph. Of course, don't forget, we're actually trying to solve the simultaneous equation using graphical method. Okay, so the first thing that we need, of course, is our title, which, like I said earlier, is going to comprise of the equation that you are plotting the graph for. The next thing is for us to bring out our table. But before we even bring out our table, let's check out our axis. Okay, so we have the y-axis, and we also have the x-axis drawn, which you are supposed to use your ruler to draw. And because of our table, because the nature of what we have in our table of values determine what our scale will be. So let me bring out the table again, the table that we have already derived. Okay, so for this equation here, we know that this is the table. Okay, so for the second equation, because I'm saying this because you need to consider the two set of values you have when you are plotting more than one graph. I mean, you are making more than one plot on a graph sheet. Yes, you should consider the two tables for you to choose an appropriate unit that will be suitable for the two tables. Okay, so now for the other table, if you have this, of course, you agree with me that this table is for this equation. Okay, it's for this equation. So if you look at it very well, we can easily pick an appropriate unit. In which case, if you look at your x-axis here, okay, you can see the values are few. Meanwhile, whatever you are drawing, you should give a room for you to have something big. Okay, so that's why I'm thinking we should just use a 2 centimeter to represent 1 unit. Okay, that's for our x-axis. For this axis, 2 centimeter represent 1 unit. Okay, so if that is the case, and you also know that by our 2 centimeter, it means we are counting 10 inner boxes. That's from here. If you check it very well, we have already explored this when I was giving you the introduction to the graph. Okay, all right. So from what you have there, you can just go ahead with that. Looking at our x-axis, we can do the calibration. So you can see, so that's 2 centimeter mark, representing 1 unit. So let's do it for the positive side and for the negative side. Okay, so we have our X label there. Okay, so the same thing now, let's put the values for the X. Okay, 1, 2, that's what I mean by 2 centimeter representing 1 unit. So for each calibration is 1 unit value. Okay, so we have that. For the negative side too, we put that. Now let's check out our y-axis. Looking at the values that we have there, this is the value we have for y. We want to choose a scale that will be suitable. Of course, it's fine for us to choose 2 centimeter to still represent 1 unit. Okay, so if we're choosing that, we can simply just calibrate it straight up like that. We calibrate it. Okay, you can see. Okay, let's plot the graph right away. Before we do the plotting, of course, we know the title comes first, which is the graph of the equation that we're trying to solve simultaneously. Okay, so the next thing is for us to put up our axis. For the y-axis and for the x-axis. Okay, now the next thing is for us to determine the scale that we are going to use. Meanwhile, to consider the scale, we have to check our tables. Okay, so now let's take a look at table 1. For table 1, of course, you agree with me that this table belongs to this equation. Yeah, it belongs to that equation there. And we can check out table 2, which we also agree with me that is for this equation. Okay, so from what you have there, you have the table, and we need to determine our scale for x-axis. To determine the scale for the x-axis, all we just need to do is to check out our point. Okay, so for x-axis, if you look at it very well, we have this, and we also have this, for x-axis. So suitably, it is convenient for us to just use 2 centimeters to represent 1 unit. This is what I mean by that. On x-axis, of course, we choose for y-axis 2 centimeters to represent 1 unit. This is what that implies. So on the x-axis, we have the calibration and send there. Can you see? Okay, so that's 2 centimeters. So let's do the numbering of the axis for us to see the implication of what we are talking about. Okay, you can see the negative side of the x-axis. Okay, so that's that for the calibration of x-axis. Now for y-axis, if you want to determine the accurate scaling, if we are determining that, of course, the first thing we have to check is our axis, the set of value that we have there. 2 centimeters to represent 1 unit will be suitable for our y-axis. Because looking at our value, so if you're using that, by implication, it means we'll be having a calibration. Okay, that's the calibration, while we get it numbered as appropriate. The negative side too. Don't forget to put your 0 mark in any case. It's very, very important. The 0 mark. All of them have a common point for 0. So that's where the two axes meet. And that's the origin of the, either you're going towards the positive side or negative side of the axis. The next thing is to start plotting the points. Starting with the first equation, to plot the graph. Okay? So if we're starting with that, that means we first of all pick the first point. That's -3 and 0.5. That's when x is -3. You check the axis x. This is when you have -3. 0.5. Of course, on our y-axis, 0.5 will be somewhere here. So what do? You trace the line from that point. You trace it. So if you trace it, where they meet, it's where we have our first point, which is going to be there. Now, taking a look at the second point, that is when x is equal to 0, which is here, y is equal to 2, which is here. So obviously, the point where they meet is that point, and that's where we're going to be having our point. And the last point, which is 3 and 3.5. You look for where you have 3 on your x-axis. And 3.5 on y-axis. That's here. So you trace it. You trace it. Where the two lines meet is where you have our point. So once you have done that, the first thing is, of course, you use your ruler to join the. So once you bring your ruler in, then you draw the line. You join the line. You have the line for the first graph. So the same thing you're going to do for the second graph on the same axis. So you trace out the first point, that's -3 and 4.5. -3, 4.5. And then you have 0 and 3. Okay. And we have a 3 and 1.5. Which, of course, with your ruler, you can conveniently draw the line. You can see. It's very important. And make sure, in any case, your line should extend beyond. You can see they extend beyond the last point. So don't just say that because your point stop here, then your line to stop there. No, it should extend beyond the point. You can see, they all extend beyond the point. So that is our graph. Now let's solve the question. What will then be our answer? Because very simple. What you just need to check is where the two lines meet. Look at it here. The two lines, they meet here. Can you see? So if you have gotten where they meet, then you trace it out. The coordinates of that meeting point. So where the 2 points meet, because if you trace it down, you can see it falls on 1 on the x-axis. If you trace it to the left, that's towards the y-axis. You see it meets at that point, because that place you can 2.5. That place is 2.5. You can conveniently say our x value is 1 and our y value is 2.5. Let's take a look at a special case here. We have if x plus y equals 2, y minus x plus 1 equals to 5, find the value of x. So when you have an equation like this, of course, this is like 2 to 3 in one equation. For instance, looking at it the way it is, x plus y equals to 2y minus x plus 1 equals to 5. So there is a way you can do the grouping. You can do it in 2 ways. Either you group this and this together, and group this and this together, or you group this and this together, then you group this and this together. So with that, you can form your required equation to solve the question. From what you have there, you agree with me that x plus y equals to 2y minus x plus 1. Because we took the first route. If you collect your like terms, eventually you have that, and you can say you have your first equation. Can you see what happened there? So you can see the simple thing we did was pick this and this first. So that has given us our first equation. For the other equation, okay, 2y minus x plus 1 equals to 5. Okay, that's picking it from here. You have that. So if you're picking that, by implication, if you collect like terms, you should have minus x plus 2y equals to 5 minus 1. So minus x plus 2y equals to 4. Okay, that should be our second equation. So what do we do next? We solve them simultaneously. If we were to use a substitution method, we can say from equation 1, 2x minus 1 equals to y. This is what we are referring to. This equation 1. From there, if you make y the subject of the formula, you have 2x minus 1 equals to y. So you can tack down on equation 3, which we can invariably write as y equals to 2x minus 1, which is equation 3. And from there, you can substitute the value of y, 2x minus 1, into equation 2, which is this. This is our equation 2. And we simply want to substitute the value of y here into this place. So meaning that we are replacing y, as it were. Okay, so which we can just do. So replacing y by this our value here. Okay, so from there, you can then proceed to simplify further. Expanding the brackets will give you 4x minus 2. That's minus x plus 4x minus 2 equals to 4. So from there, you have minus x plus 4x equals to 4 plus 2. And 3x equals to 6. X is equals to 2. So you can substitute x equals to 2 into equation 3. Of course, I've already said it. When you're doing substitution method, the equation you created, make a safe way to determine the rest of the values, as the case may be. Okay, so that means we have y equals to 2x minus 1. So if you slot in the value, you have your final answer. That's y equals to 3. Okay, so now let's take a look at another case of one linear, one quadratic simultaneous equation. So you can have something like that. By linear, we mean the highest power of the variable there is 1. By quadratic, we mean the highest power of the variable there is 2. Okay, so if you have that, what we'll do is we, of course, write them out as equation 1 and then equation 2. Of course, for question like this, substitution method is the most suitable option. Yeah, I mean the method to use. You can use graphical method too. Very sweet something. You can use graphical method to solve this. It's still the same procedure. Graphical method, substitution method seems to be a little more direct. Okay, so from equation 1, we have x equals to minus 1 minus y. Okay, that's equation 3 as usual. So the next thing, we put our equation 3 into equation 2. So if we do that, we have this. Of course, you expand minus 1 minus y. So by expanding it, it's going to give you a quadratic equation, which of course you can solve using any of the method that you have learned so far. 2y squared plus 2y minus 12 equals 0. So another thing we can do is we can reduce the value by dividing through by 2. If you divide through by 2, you have a y squared plus y minus 6 equals to 0. The essence is the smaller our value, the easier the solving a lot of times. Okay, so if you have to factorize this, it should give you this if you factorize it properly. And after the factorization, you can then sort out the value of y. Of course, by implication, y equals to minus 3 or y equals to 2. If you substitute the value of y in equation 3, of course, picking equation 3, when y is equals to minus 3, x is going to be minus 1 minus 3, and then it's equals to 2. When y is equals to 2, so what we are simply doing is checking for value of x for the individual value of y. This value of y is another value of y. So we're checking for the value of x for the individual value of y. So we can then state x is going to be minus 1 minus 2 plus minus 3. So we can therefore say x comma y, I said it earlier, to write it in this linear form, x comma y equals 2 comma minus 3 or minus 3 comma 2. So let's take a look at word problems. Look at this question. The sum of two numbers is 31. Why their positive difference is 13? Find their product. Okay, let the two numbers be x and y respectively. Okay, so according to the question, it says the sum of two numbers. So that sum can be represented as s plus y, which is equals to, according to the question, 31. That's why we have this. Okay, why their positive difference? Positive difference means when you subtract y from x, of course, or x from y. When you subtract it, it gives you 13. That's the implication. So we can take this our equation 1. Then for the second part, that's a positive difference, which is going to be this, is 13. So, which you can then, of course, tag equation 2. The question says that we should find their product. That's the product of x times y. That's product of x and y. So from what you have there, you can conveniently eliminate y, of course, using elimination method by adding equation 1 and equation 2. So if you do that, of course, we are adding, and we can just add it straight up. S plus x will give us 2x, plus y minus y will give us 0, and 31 minus 13, plus 13 is going to give us, because this plus sign is cutting across everything, that's 44. So we can then divide both sides by 2, and that gives us 22 as our answer. Okay, that's the value of x. So you substitute the value of x into the equation 1. You can use either equation 1 or equation 2, but we're picking equation 1 in this case. That implies that we have 22 plus y equals to 31. Y equals 31 minus 22. So y equals to 9. Okay, the product, of course, which is what the question says. The question says that we should find the product. You find the product. The product is going to be 22 times 9, which is going to give us 198. Let's take a look at another question. Now, from a shop, Sunday bought 4 mangoes and 3 apples for 10 naira, while Wale bought 3 mangoes and 2 apples for 7 naira. How much will Bola pay for 2 mangoes? How much will Bola pay for 2 mangoes and 6 apples bought from the shop? So the first thing is to interpret. Tunde bought 4 mangoes. So we will call our mango M, using M to represent mango and using A to represent apple. Okay, for 10 naira, meaning 4 in the multiple of the value of 1 mango. That's going to give us 4M plus 3 times the cost of 1 apple, which is going to be 3A. 1 apple is A, 1 mango is N. Okay, so if you multiply it together and you add it together that way, I'm just taking you through the process of the interpretation. So that means you have 4M plus 3A equals to 10. You can tag down your equation 1. Okay, so for the second one, Wale bought 3 mangoes, that's 3M, 2 apples, that's 2A, for 7 naira, which is what we have interpreted here. 3M, 2A, plus to 7 naira. Okay, the rest to solve simultaneously. We decided to eliminate, using elimination methods, to eliminate M. You know what that implies? That means there will be a flipping of their coefficients. This one will multiply by 3 times 3, and this one will be multiplied by 4. Okay, so that means we have a multiply by 3 will give us this. And multiplying it by 4 will give us that. Are you still with me? I wanted you to process it, that's why I paused a little. Okay, so that being said, we can then, of course, we subtract equation 4 from equation 5. We subtract equation 4 from equation 3. If you do the subtraction, okay, we do it that way. So by subtracting, it implies that 12 minus 12 is 0. 9A minus 8A. Don't forget the minus we cut across everything. So minus times plus will give us minus. So that's minus 9A minus 8A. And the same thing will happen here, minus. So that means we have A equals to 2. If A is equals to 2, then we can substitute A into equation A. Then we can substitute for A in equation 1. If we substitute for A in equation 1, that means we have 4M plus 3A equals to 10, 4M plus 6 equals to 10, 4M equals 10 minus 6, and then 4M equals to 4. If you divide both sides by 4, you have M equals to 1. So we have our value of M and we have our value of A. Now look at the question. How much will Bola pay for 2 mangoes and 6 apples? Okay, so we already know that 1 mango is 1 naira, 2 apple is 2 naira. So that means Bola will pay 2 times the cost of mango plus 6 times the cost of apples, so which is going to be 14 naira. It's as simple as that. Okay, so you have to solve the following questions. Take a look at them, go through the solutions again. If any area is not clear to you, you can ask questions in the comment section, and as much as possible, just replay the video. You will understand whatever you don't understand initially. Yeah, I believe so. With that, we've come to the end of this lesson on simultaneous equation. Thank you so much for your patience. I don't take that for granted. Thank you. Make sure you share the link to the video, like, and if you have not subscribed yet, please go ahead and subscribe to the page so that you can get notification, first-hand notification once another video drops. Thank you.